Okay, good morning and welcome back. I hope we had a great weekend. Our quick look at the calendar here. Today is our last day of new material before the quest, which is coming up on Wednesday. So today we do in-context problems, that is word problems. And then we have our full period quest on Wednesday and then new material on Friday. Any questions on the calendar? All right, so in terms of the quest, I wanted you guys to open to page 60 because that is where you will find practice problems for quest number 2. This is a really good resource in terms of studying and preparing for the quest on Wednesday. And if you go a couple of pages down the road, I don't know where I went, should be able to find answers to those problems. All right, so as I was saying, if you go a couple of pages past page 60, you will find an answer key to the problems. Is it down here at the bottom? There we are on page, whatever page that is, 62. Answer key is there, and on YouTube, you'll find videos of me going through each of these problems. And if you wanted to know how to find those videos, you can either go through Moodle or you can type in phrases like this one right here at the top of page 60. Okay? So lots of good resources, so check them out as you prepare for Wednesday's quest. So the new material that we're on is just a couple of pages earlier here. So we're going to start today together on page 53. But before we do, I want to take a quick detour to this one-page handout that is on your table. So go ahead and grab that one page that's on your tables. So we've spent some time in the previous few classes just learning how to write equations of lines. Given 2 points, find the equation of a line that hits them. Given a line, find the equation of a line that's parallel to the first one and passes through such and such a point. Lots and lots of finding equations of lines. But a number of folks are still struggling with one piece of that process, finding the equation of the line. So I wanted to write up a step-by-step process that hopefully is easy to follow. And that's what this is. So I want us to go through this process and do 2 example problems at the bottom, just to really make sure that I want everybody comfortable with writing the equation of a line. So the first example that we're going to do is right here around the middle of the page. We want to find the equation of the line that's perpendicular to this line and passes through the point 4, -3. Now some of you guys could do this start to finish without batting an eye, so just bear with us if you are one of those people. But here's the process. Step A, write both coordinates of a point on the line and circle these coordinates. If you have 2 points given to you, pick either point and circle its coordinates. So what point do we have given to us in this example? What is it, 4, -3? And then I asked you to circle it because we're going to reference that circled thing later on in this process. Okay, part B says write down the slope of the line. This may require some calculating on your part, and there are a couple of examples here. You might just need to use the slope formula if you're given 2 points. Or you might need to use the fact that perpendicular lines means the slopes are opposite reciprocals, or you might need to use something else. So finding the slope is generally some work, whereas finding a point is usually just grab the point. So what's the key word in this problem that's going to help us find the slope? Is perpendicular. So we see perpendicular, and we know that the slope of the line that we want is the opposite reciprocal of the slope of this line. Is this line in a good form to be able to just read its slope? It's not. What would we really like that line to? We want it to look like y equals, right? Because if that line looks like y equals, then we can read the slope. So we solve this guy for y by adding the 2/5 x to both sides. And so coming over here, that means the slope of this line is how much? Wrong, you picked the wrong one. 2/5. Right, we know it's mx plus b, so the slope is the number touching the x. So the slope of that line is 2/5, which means that the slope of the perpendicular line is negative 5 over 2, right? You do two things. You change the sign and you flip it over. So that negative 5 over 2 is the slope that we want. So I'm going to write that over here. M equals negative 5 over 2. And that's what I mean when I say usually finding the slope requires some work. Sometimes it's given to you, but most of the time you got to do something to get it. All right, moving on to part C. It says write y equals mx plus b. Now, I know it's easier just to start substituting immediately, but I think that me having you guys write out a couple of extra things in steps C and D is going to help the folks that are having trouble finding that y-intercept. So I encourage you just to write y equals mx plus b every time we do one of these problems. And then step D says in the equation above, the y equals mx plus b that we just wrote, replace the m with the slope and write the equation, which will look like something like this. Y is equal to some number times x plus b. So what we're going to do is copy that equation just as it is, but instead of the m, we put the m that we calculated. What did we calculate for the slope? It was negative 2/5, or negative 5/2 was our slope, right? X plus. So this is the tricky part right here, and in fact, it's this piece that we're about to write down, which is what led me to creating this sheet yesterday, is that a lot of people are going to look at that and say, okay, I just replaced the slope with the number, so I got to replace the b with another number, and some people are going to look over here and they're going to say, oh, the b is 7, and we'll put a plus 7 here. But that y-intercept is not the y-intercept we want. Some other people will say, oh, I need a y value, so I'm going to grab negative 3. That's the y value for the point. It's true, but it isn't the y-intercept. And so it's this step right here that I think is crucial for folks that are having trouble with this process. What am I saying you should do? I'm saying you should write y equals some number, we got that, negative 5/2, times x plus b. Don't change the b, copy the b, just leave it. All we're doing is changing one thing, changing the slope, the letter m into a number. That's it. I think writing that equation is going to help a lot of people. Okay, next step, where'd it go? It says E, rewrite the equation from the previous step, but replace the x and y in the equation with the coordinates of the point. Oh, I think we're supposed to star something too. It says put a star next to the equation that we wrote here. That's just so we can refer to it later. Okay, so step E says you take the equation we just wrote, you're going to replace the x and the y with the coordinates of the point that we circled way back in step A. So x and y become 4 and negative 3 respectively. Everything else gets copied, which means which of these three letters, y, x, and b, is still going to be there when I copy? It's the b. We're changing the x and we're changing the y. Both of them become numbers, but the b stays. So here's the goal for this step. Some number equals some number times some other number plus b. It's that b right there that is tripping some people up. So let's put it here. All right, what do we have here? Y. How much is y at the point that's circled? Negative 3 equals. We're just copying the equation at the bottom. Negative 5/2 times x. How much is x at the circled point? It's 4. Plus, how much is b? It's b. We don't know. You can see it just barely at the top of this screen. It's still there. Okay, and then we have a little bit of work here to do to solve for b. That's what it says in F. Solve the previous equation for b. So how about we clean this equation up just a little bit. Negative 5/2 times 4. That simplifies. What number is that? Close. Negative 10, thank you. plus B. And then add 10 to both sides. And finally, after all that, we get B is 7. Which is unfortunate. I didn't mean for it to be this number up here. You guys, do me a favor, change that 7 right there to a 9. It's just a coincidence that it happens to be the same number, and I don't want that to happen. So the original equation I wrote with an equal 7, just change it to a 9 so it doesn't look like that 7 has popped up again. It's just a coincidence. Okay, and then last step is G. Plug this value for B, what we just got, into the equation with the star. So that's over here on the left. So you get an equation like this. Y equals some number times X plus some number. That's the finished product at the end of this game. So Y equals, what's the first number? -5/2 X. So I'm just copying the star equation. Plus, instead of the B from the star equation, what did we get? We got 7. Any questions on the process? That's right, perpendicular. Yeah, how do you find the slope for two parallel lines? They're exactly the same. So in this problem, the slope of the purple line was 2/5, right? So if it said parallel, then what would the slope that we wrote down in part B say? It would also say 2/5. So you would just copy it. Yeah. Other questions? Okay, so there's another example here. I want us to do our today's lesson together for a few minutes and then ask you guys to come back to here in your groups and see if you can work through that and get to the answer at the bottom. So let's hold on doing that other example and come back here to page 53. All right, so we'll start at the top of page 53. Abby, can you read number 1? Thank you. Tim? Okay, so here's a real standard kind of problem that we'll be able to work through. Essentially, we just have to take all of the information given to us and break it down into data that we can handle. Essentially, just ordered pairs, 2 points. So first, we're going to do part A. It says define the two variables, identify which is independent and which is dependent, and we'll include units. So you guys did a lot of this if you took 095 here. So to figure out what the two variables are, what do we have? It says we have sales, and those are growing at a constant rate. And what's the other thing that's changing in this problem? Is time. So I got 2009 and then and then 2005. And then sales are these numbers, right? 215 up from 28 million. So it seems like those are our two variables, is sales and time. Which one feels like the independent one? It's time. If time is in a problem, it's almost certainly the independent variable. Time just moves along, could care less about what this company was doing, but as a result of time passing, the amount of money that this company generates changes. So independent variable is time in, and then we got to make up a unit. So what would be a good unit for time? years for this one. And then the dependent variable is sales. And what's a good unit for this? Yeah, it seems like millions is millions of what? Dollars. Seems like that's better than using dollars, because if you just say dollars, then you're going to have to write out the number 215 million in every one of your equations. So millions of dollars seems better. And while we're trying to make our life easier, let's go back and revisit time. Because if we just do time in years, then one of our values is 2005, like literally the number 2005. And the other one is 2009. And if I'm imagining plotting these things, I'm out there in the thousands someplace. How about we reinitialize? Maybe we could say years since some starting number. It's up to us. Years since what? Did you say 200 or 2000? Yeah. How about years since 2000? Just to make the numbers smaller. Years since 2000. You don't have to make that choice. And if you make a different choice, then your equation will be different. But that's okay. All right, so let's have a look at part B. We'll go back to Karen for B. Okay, so let's get some ordered pairs in here. Oh, I forgot to introduce a letter. How about we give a letter in here? When we had time in years, what letter do you want to use for that? Use T for that. Okay, and then sales. How about we go with S? Be careful that your S doesn't look like a 5. Okay, I'm going to write two things, but one of them is wrong. Should my ordered pairs look like S and then T, or T and then S? Which one goes first, the dependent or the independent? Independent is the one that goes first. So which one of these is right? Is the T and the S. Okay, which means I can take the data in the problem and just break it down to a T followed by an S. So what was the first year given in the problem? 2005. What are we putting for time for 2005? It's just plain 5 because we're starting the clock at 2000. So 2005 becomes 5, comma. And then what were sales in 2005? Was it 28? Okay, and then we play the same game for the other piece of info. What was the year? 2009, so what are we putting? Just 9. And then sales increased quite a bit. What were they up to? 215. Any questions on getting to that point? Okay, and at this stage of the problem, and for the next large chunk of this problem, we're going to ignore all the information about breathalyzer and sales and all that. I just have two ordered pairs, 528 and 9215, and I can find the equation of the line that hits those two things. How do I know I'm supposed to find the equation of a line? What was this one word up here? Where'd it go? It said assume sales are growing at a constant rate, meaning every year they grow at exactly the same dollar amount. That's a line. So let's come down here. I'm going to skip part C just to save a little bit of time. Part C asks us to plot some points, but it also means we'd have to come up with a good scale to put on the axes. I don't need to see these points. Let's just go through the process to find the equation. All right, you guys still have that one piece of paper that I handed out today nearby, right? Let's go through this process from that piece of paper. What does step A say to do? Let's write coordinates of 1 point. What does it say to do if you have 2 points? Pick one. Makes no difference. Let's pick the first one, 5, 28. And just because I know we're coming back to this later, I think I asked you guys to circle that one as well. So we just pick either point, write it down. What does part B ask us to calculate? Slope. In order to find the slope, what are we going to do? y2 minus y1, that whole equation, right? That's what we have. So I'll write the formula here, m equals, so I'm going to write it in the shorthand, change in y over change in x, with that little delta symbol to represent change. But then I'm going to ask us to use the letters that are relevant in this problem. We don't have y. Which one of those letters up there is y? Is the s. So I'm just going to write it this way, change in s over change in t. Okay, and now we'll get into the calculation. So what am I subtracting up here first? Thank you. Just got to make sure that we subtract the s's on top and the t's on the bottom. Lauren.
You always say that it's like, does it matter if which way you put the subtraction, but how do you know if like in case?
Yeah, so it doesn't matter which way you subtract, but whether it's positive or negative will come out at the end. If we had done the other order, 28 minus 215, right, going the top one minus the bottom one, then downstairs we'd get what? We'd have to do 5 minus 9, right? Yeah, and so let's do these two things. You see it? You have to be consistent. You definitely can't mix. Okay, so what do we get upstairs when we subtract? Blue. What is it? 187? Thank you. Divided by 4. Okay, and generally I'm a fraction guy over being a decimal guy, but oftentimes in word problems, decimals are more natural than fractions. So this guy as a decimal. This? Okay, 46.75. Okay, so we've got our slope. And in part C, asks us to write something that's always the same. What are we writing in part C on that sheet? Right, y equals mx plus b. But again, let's use the right letters. We don't have y in this problem. What do we have? We have s. So it's s equals m. We don't have x. We have t plus b. So we just write the whole thing out, all the letters, and then slowly we replace these letters one at a time. So the next step on the sheet says you copy that equation that we just wrote, but you make one change. You replace the m with the slope. So I'm copying everything in this equation except for the m, which becomes what number? 46.75. So S equals 46.75 T plus B. And again, be really clear with your writing. T's look like plus signs, S's look like 5s. Okay, the next step on the sheet said you go to the point that you circled. It's up here at the top for me. And you change the X and the Y into those numbers. But again, it's not X and Y, it's T and S. So which one of those numbers, the 5 or the 28, is the S? 28, so let's go here. So 28 equals 46.75 times T is 5. That 5 goes there. Plus, what do we change the B into? Nothing. It's just B. And this equation is what we use to find B. Okay, so we need to do that multiplication. The goal is to solve for B. So we just need to multiply here. What do we get? 230, another, thank you. And then we'll subtract that 233 from both sides. As in 5. All right. Yes? Okay, and then our last step. Oh, I forgot to put the star someplace. I think we were supposed to star this equation here. So I'll put a star over on this one as well. We're just going back to the starred equation and we're making one small change. Which letter is getting substituted out? The B that we just found. So we copy everything else from that equation. S equals 46.75. Running out of room here. Let's try it below. S equals 46.75 T minus, and then the B we just came up with was this 205.75. Questions on the process? All right, so I can say definitely on the quest on Wednesday, you're going to see something like this, where I give you a word problem, but essentially, if you're very careful, you can take that word problem, all the information that was in that paragraph, and just boil it down to 2 points. And once it's 2 points, we have a familiar process that we can follow to get the equation of the line. Now, of course, there's always going to be some interpreting questions here. We'll do that now. But the idea for this problem is just find the 2 points that are in all that data and then follow the familiar process for the equation of the line. All right, let's go to Kyle for E. Okay, so we know what the slope is. What did it turn out to be in this case? What number? Was this 46.75? So that slope means something. It has to do with sales and it has to do with time. But in order for me to think about slope, I always like to write the units down. What were the units upstairs? What were the units for S? It was sales and it was in millions of dollars. And what were the units for T? It was years. And then since 2000, I won't include that part. But that means that the slope has units, millions of dollars, and then I'm going to use a not very math word or a word that's common outside of math class instead of the division line. It's millions of dollars divided by years, but what's the more common way to say that? Is per. Millions of dollars per year. And if I ask you to interpret slope, probably using the word per is going to make it so you understand what that slope actually represents. So this is $46.75 million per year. Okay, so let's get our sentence in here. Something was changing by $46 million per year. What was changing? Was it time or was it sales? Sales. So we just have to start the sentence with sales. Sales were. Now you could say changing. And in fact, you could probably say changing in just about every interpret the slope question. But I'd rather not use the word changing. I want to get something a little more precise. That 46 million was a positive number. So that means that sales were growing or increasing. By how much? $46.75 million. And then we just finish our units. What were they? Per year. That's the sentence. And getting the sentence is a process, but it's the same process every time. Write down what the units were because we did the slope calculation. Figure out what it is that's changing. Was it time or was it sales? It was sales in this case. In fact, I can tell you that, I mean, if you're a memorizing kind of person, the thing that's changing is always the letter that's on top. It was S in this case. Sales were increasing. And then get the word increasing or decreasing in there based on whether that slope number was positive or negative. And then write the number, and that's pretty much it. That's the process. Okay, part F says predict the value of personal breathalyzers in 2013. So how do we do this? Let's plug in 13 for T. That's it. Okay, so that means S equals, copy all this, 46.75 times, instead of T, 13, minus this 205. What is it? Was that exact, or was there? Anybody else get this? Yep, good. Okay, and then it says write a complete sentence to interpret the answer. That 402 represents what? What are the units for this 402? Millions of dollars. So we just have to write it. The model predicts sales were $402 million. When? In 2013. Questions on that? Okay, so the group activity is here. It says something about working on the whiteboards. Let's not do that. But let's have each group work through each of these problems. But I'm going to ask you guys to start on different ones. Maybe actually, Alex, you can move and join another table. You can join Boo or wherever she's headed. And so let's have people start on different ones. So this table will start on number 1, 2, and 3 back there. You guys can start on 1, and you two can start on number 2. And raise the flag if you get stuck.